Good morning, guys. Welcome back. Welcome back to school. We've got to get back in that school mindset, and we are ready to go. I can see it in your eyes all the way through distance learning that you are excited about getting back to learning, especially about fractions and math. I can just see it in your eyes that you have missed this so much, just like I have, and we are ready to go. So we are at Module 5. And we are at lesson 1 of module 5. Now these are the 4th grade fraction lessons. These are brand new lessons to us, so I really need you to do your best to watch these videos, listen really well, and try your hardest on the problem sets, and let's get a good start to this module. Okay, so module 5, lesson 1, here we go. We're going to jump right in. We're going to do just a tiny bit of practice to get our math brains warmed up. Let me find the right slide. Where did it go? There we go. Okay. Now, if you need more time to work the problem, then you have a pause button. Y'all know how to find pause and pause the video if I start back up talking about it. Okay. And you're not quite finished or quite ready, you can use that pause button and then push play again when you finished it. But we're going to start here with these 3 review problems just to get us thinking, and also we sure don't want to forget all the hard work that we did several weeks ago with all of this. So if you would, get your scratch paper. Remember, you're going to use scratch paper and a pencil at home instead of a whiteboard and marker because we did not send those home. Okay, so if you would go ahead and turn this problem vertically and go ahead and work 52 times 82. Even though they've listed the smaller number first, always good practice to put the larger number on top. So turn it and go ahead and work that problem out right now. Okay, so hopefully you've worked that problem out. I'm going to go ahead and work it for you just to help you check your answer. Okay, remember with 2-digit by 2-digit multiplication, we can add that dinosaur head in there, and that reminds us to put the dinosaur egg in the problem a little later on. 2 times 2 is 4. 2 times 8 is 16. The dinosaur head helps us remember that now that I'm done with that 2, I'm going to put a 0. I know I'm a little squished in here right now. We're going to make it work. Okay. 5 times 2 is 10, so I put a 0 for that and carry the 1. And then 5 times 8 is 40, plus 1 more is 41. We're going to add that up, and our final answer should be 4,264. So hopefully that's what you got. Okay. All right, let's clear that off. And now if you would, set yourself up to solve 4,284 divided by 6. Go ahead and write it in the other form that we have practiced so much. We would write that as, I'll move up here to do that, 4,284 divided by 6. Okay, you can stop the video now and work the problem out and then check it and see if you've gotten it correct. You can also check it with multiplication to see if you've gotten it correct. Go ahead and do that now. Okay, we're going to check this problem. How many 6s can I get out of 4? Well, none, because 4 is too small. But I can look at 42. I'm going to grab that next digit. So how many 6s can I get out of 42? Well, that rings a bell. There's a fact family there. I know that 6 times 7 is 42. And I'm going to subtract that, and I'll get 0, and I'm ready to bring down my next digit, which is that 8. If I have 8, then I can get one group of 6. 6 times 1 is 6, so we subtract that. Okay, we subtract that and get 2, and we're ready to bring down the next digit. How many 6s can I get out of 24? Again, that fact family, I know these so well by now that that's ringing a bell. I know 6 times something is 24. 6 times 4 is 24. 6 times 4 is 24, so I can subtract that exactly, and I get 0. I have nothing else to bring down, so I have no remainder, no more digits to bring down. So my final answer is this. If I wanted to check it with multiplication, 6 times 4 is 24. 6 times 1 is 6, plus 2 more is 8. 6 times 7 is 42. And there's my answer there, which matches this right here, our dividend. Okay? All right. So there's our good warm-up for some division, long division. Okay, our last warm-up is list the factors of 18. Okay, factors. First, I've got to remember what that is. Factors, factors, factors. Oh yeah, far fewer factors. Remember that. Okay, so I know that this is not going to be the list that goes on forever. That's multiples. It's like multiples. Remember the skip counting? That's multiples. Factors are the numbers that I can multiply together to equal another number. So if I want the factors of 18, it's we're going to make those arcs that look like a rainbow. I know that 1 and 18, 1 times 18 will equal 18. I know it's even, so I know 2 is a factor. Okay, 2 times 9. And I should have told you to make this list, stop the video, and then check yourself. So anyway. All right, what else makes 18? Well, I know from my multiplication facts, 3 times 6 is 18. And I don't really know if I need both of those commas right there because the only two numbers left in between 3 and 6 are 4 and 5. Well, 4 times 4 is 16, and that's pretty close, but because that's so close, I'm not going to be able to multiply 4 times anything to get 18. So 5 is not going to work with 18 because this number doesn't end in a 0 or a 5. So, all those little kind of tricks that we've talked about and worked on. So I'm going to get rid of that comma right there. And there is our list of factors for 18. So even if you didn't have time to work this on your own, I hope that me working it with you right now is reminding you of what factors are. Okay? All right, so let's clear that off. That's just kind of to get our minds going. All right, we're going to jump in here. I've lost my place on my slides. Let me find that right quick. There we go. Okay. So when you get to the next slide, if you're looking at your slides at home, some of these we will do and some of these we will jump over. We're just going to make sure we pull out the important ones. I think you're going to possibly notice that several of them talk about you using paper strips and folding your strip. If we were here in person together, we would do that. We would fold our paper strips, just some little skinny paper strips that I have, to make some paper fractions to lay in front of us. I did not know how well that would video and show up for you at home. So I'm going to draw this on the board rather than us fold paper strips. But if you'd like to try that at home, cut a long rectangle, kind of like a tape diagram shape, and try to fold these fractions up, you can do that on your own time, no problem. All right, so because this first slide is mainly about folding the strips, let's jump on to this one, okay, the next one. All right, so here we have a paper strip that is 3 pieces long. This right here is one whole, okay? Let me change to that color. All right, we have seen a tape diagram several times where we call the whole thing one whole piece. And we see that it's been cut into 3 equal pieces, okay? So it's important for this lesson and several other lessons that we get the fact that, oh, if that's one whole, I can figure out my denominator by counting up the total number of pieces. Because remember, our denominator is the total number of pieces in the whole. So this one whole has 3 pieces in it. It's a little hard to see on here, but 2 of them are shaded. this one is shaded, and this one is shaded. Okay, so 2 pieces are shaded. We have 2 of the pieces, and there are 3 pieces total. Remember what our numerator and our denominator tell us. Okay, so what they're trying to ask you here, it says, let's show the decomposition. Remember, decomposition is just pulling something apart. Okay, it's just a fancy word for pulling it apart in another way. All right, so they're saying 1 whole is equal to 1/3 plus 1/3 plus 1/3. That's true. If we have all 3 pieces, we're going to have 1 whole. Okay? But notice the little parentheses. They're trying to encourage you to group them a little differently. So what is a different number sentence, and a different addition sentence we could write if we grouped these 2 unit fractions together? Okay? Now this may look super complicated, but once you see how this works, it is super simple. If we put these 2, if I have 1/3 and 1/3, well, together they're going to be 2/3. Okay, if I have 1/3 and 1/3, remember our pizza? Okay, if I have 1/3 and 1/3, let's just use these 2. If I have 1/3 and 1/3, I'm going to have 2/3. Okay. Okay, so 2/3 plus the 1/3 is also equal to 1 whole. So how can I get this 1 whole? Well, I could decompose them into all separate unit fractions. 1/3 plus 1/3 plus 1/3. That's one way to do it. Or I could group them a little differently and still get my 1 whole. 1 whole is also equal to 2/3 plus 1/3. It's just a different way of adding these same pieces. Okay, let's keep moving. All right, so if we have this tape diagram, and I know it's a paper strip, and they've asked you to double the unit, so now we don't have thirds anymore. We have a different denominator now, a different unit fraction. Okay, so how many are there? If this was our 1 whole, okay, to figure this out, don't get tricked by this. To figure this out, we need to count how many pieces are in the 1 whole. So we've got 1, 2, 3, 4, 5, 6. Okay, so we know that our denominator, we automatically know that is going to be 6ths. Okay, all right. Now, the shading is a little bit hard to see on this, so I'm going to kind of shade on top of that for you. This one is shaded, and this one is shaded. This one, and this one. Almost all of them, but not quite. All right, so if this equals 1 whole, but this is the fraction that we have, how many pieces do we have, or how many pieces are shaded? That would be our numerator. 1, 2, 3, 4, 5. Just 5 of them. But there are 6 pieces that make 1 whole. So that is our denominator. Okay. So if we are going to decompose, okay, let's write an addition sentence. Okay, and I'm sorry, because of the paper strip thing, we're jumping over a lot of this. But if we're going to write an addition sentence for this right here, look at how many blanks they've given us. 1, 2, 3, 4, 5. So if we broke this into 5 pieces, what would our addition sentence be? Well, there's only 5 pieces shaded, so each of these would be 1/5, 1/5, 1/5. Whoop. I'm going to write that one backwards. 1/5, 1/5. Okay, now I've just done that, but I did something incorrect. I wonder if you know what I've done. If you need to pause this and look at this for a second and try to figure out what mistake did I make, do that. Okay, so by now I hope you've looked at this long enough to figure out what mistake Miss Wendy has made. Okay, there are 5 pieces here that are shaded, so it would have been very easy for me to write this as the answer. But what is our denominator? Our denominator is sixths. So every now and then I like to show you a common mistake that we make. Okay, this is not true. I cannot add all of these and get 5/6. What is in these blanks has to add up to 5/6. So I cleared that off. Let me very quickly put this back. Okay. Be very careful because as we move through this, I am going to show you some common areas, common things that happen that get us tricked sometimes. This is 1/6. Remember, our denominator is 6. So be careful. Now, I've got 1, 2, 3, 4, 5 of them. So adding those together does equal 5/6. Okay? Let's keep moving. All right, now, let me erase what was in there. But I want to put this back because this is one whole. Still have the 5 pieces shaded. Okay, now they took what we had just written, all those unit fractions, 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6, and now they've grouped them a little differently. Okay, they've put parentheses here and here just to show how we can group them differently. So 5/6 is equal to, how many is this all together? There's 3 of them. So that would be 3/6. And how many are right here? 2 of them. This would be 2/6. Let me show you one other way that this could look. Remember how we did number bonds? 5/6. Okay, and remember what's below the top bubble can be added together to create the top bubble. So this would be 3/6. And this could be 2/6 right here. We also could have made one of these a step before where we had 5 bubbles and each bubble had 1/6 in it. 1/6 5 times. Okay? We could also do 4/6 and 1/6 in one bubble. There are other ways to do this as well. Okay? All right. Now, once again, they're asking you to fold a strip of paper, and I'm not going to ask you to do that. I'm going to draw what they're asking you to create so that you can see it better. Let's see. Let's do it that color. What they're asking you to do is to take a strip of paper and to fold it into 4 equal parts. Let me draw this color. Now, this is really important that we see this. Because every now and then we're going to see this happen, and I want you to understand what's happening. It asks us to shade in all of the parts. Okay, so this is one hole right here. I'm going to squeeze that in right there. But then it says fold another strip of paper into 4 equal parts and to shade 3 of those. So I'm going to draw another one of these. I'm going to put it just a little bit lower so we don't bump into that number bond. 4 equal parts, but I'm only going to shade 3 of them this time. But guys, still, this whole thing is one hole, even though that one is not shaded. Okay, so this, don't get tricked by this. This sometimes tricks folks. I don't want you to get tricked by this. This is one hole. What is our denominator? What number is going to be our denominator when we work with these fractions we're fixing to work with? Look at how many pieces are in one hole. 1, 2, 3, 4. 4 is our denominator. Don't get tricked and say, oh, it's going to be 8. Look at all of those. Or, oh, it's going to be 7 because 7 are shaded. No. We have to look at how many pieces are in one whole. 1, 2, 3, 4. That's it. That is our denominator. So these are fourths. Oh, I did it again. Okay, these are fourths. Now, how many fourths do we have? How many fourths do we have? We have 1, 2, 3, 4, 5, 6, 7 fourths. Now, we talked about this before you guys left for Christmas. Are you allowed to have a fraction that has a larger number on top in the numerator and a smaller number on the bottom as the denominator? Are you allowed to do that? Yes, you are. It's called an improper fraction. Remember that. This is larger than one whole because we have filled up one whole and then we have more. This would be like having 2 pizzas, 2 whole pizzas, and we've cut both of them into 4 pieces. And maybe we ate all of one pizza and 3 of the 4 pieces of the second one. So all that's left is this little guy over here. Okay. All right. Now it says how much is shaded? Well, 7 fourths. It also says to draw a number bond to represent the 2 parts and their sum. And to write a number sentence. We'll do that. We'll squish that in somewhere. We'll figure it out. So 7 fourths is equal to 1, 2, 3, 4 fourths. Oh, I would so give a ticket out right now if you were in the room and I would say 4 fourths is equal to what number? And I would be looking for raised hands. And what would the answer be? 4 fourths is equal to 1 whole. Any number on top of itself is equal to 1. Okay? So this is also equal to 1 right here. Now, how many fourths are here? 3 fourths. So we know that 4 fourths plus 3 fourths is equal to 7 fourths. Okay? All right, so what would our number sentence be? We'll turn that green and put it up here. 7 fourths is equal to 4 fourths plus 3 fourths. Could I replace this with the number 1? Could I say 7 fourths is equal to 1 plus 3 fourths? Yes, either one of those would be correct. Either one. Okay, let's keep going. All right. So this is just a quick side note about improper fractions and mixed numbers. I will let you look at that on your own a little bit more. We'll read it. The numerator is larger or equal to the denominator in an improper fraction. A mixed number has a part that is a whole and a part that is a fraction. And this is kind of jumping ahead a little bit. We will definitely talk a lot more about these coming up. So I'm not going to spend a long time on this right now. Okie doke. But I am going to jump here because this is starting to look more like your problem set. And I want this to be real clear to you how to do this. I'm actually going to do part of the problem set with you in just a minute. Okay. Now, we noticed the tape diagram, the long rectangle thing that we've worked with a whole lot. This is a tape diagram, and we've got to pay attention to the details. I want you to really be on the lookout for the details because that's going to keep you from getting tricked. Always look for the one whole. How much is making up one whole? Okay, that's a clue. And another clue to keep from getting tricked is to look at these little brackets and pay attention to how much they're holding. Like this little bracket is just holding one piece. And this little bracket is just holding one piece. Sometimes it'll be one piece, but sometimes it'll be more. So we really, really want to watch that and pay attention to that. Okay, so one whole. 1, 2, 3, 4, 5. That one whole is cut into 5 pieces. So we know that our denominator is going to be 5. These are fifths. Okay? How many fifths are shaded? 2 of them. Now, how many fifths are in this? What did I just do? Oh, okay then. You guys know something crazy is always going to happen with the board, so let me get that out of the way. Okay. Make sure you're paying attention. All right. How many fifths are in that little bracket? Just one. How many fifths are in that little bracket? Another, just one. Again, here's a ticket question. What is this type of fraction called that has a 1 on the top? It has a special name. I hope you remember it when you come back. I'm going to be asking. It is a unit fraction. Okay. All right, just a little side question there. Now, we've named the unit fraction. We know that's 1/5 because we counted our pieces. We did not get tricked. These are fifths. Label the unit fractions for the shaded part. We just did that. 1/5 and 1/5. We are good to go. Name the shaded fraction 2/5. We've already done that. Decompose. All right, we're just going to break it apart. Decompose 2/5 into unit fractions and write a number sentence. This time we only need a number sentence. Sometimes we also are going to make a number bond. What does that mean? That sounds so complicated. It sounds so hard. What do I do? All you're doing is writing a math problem to show that this is equal to these parts. Okay? Not complicated at all. We've got 2/5, right? That's how much we have. That is equal to 1/5 plus 1/5. Okay? There we go. Okay. Let's do the same thing. Name the unit fraction. Well, before we go there, let's count how many pieces are in the whole. This is 1. I know that the bracket starts here, it comes all the way down here, and goes to here. So I know that many pieces are in my one whole. 1, 2, 3, 4, 5. Again, it's fifths. Okay? That is my bottom number, my denominator. That is how many pieces are in the whole. Okay, how many pieces are shaded? 1, 2, 3, 4. That's how many pieces we have. Okay, so these are fifths. That's the unit fraction. We're going to label the unit fraction for the shaded part, 4/5. Okay, but let's also label these right quick. Now, this is where, guys, if you don't really look closely, you're going to get tricked. How many are in this bracket? Just 1. 1/5. How many are in this bracket? Just 1 again. 1/5. How many are in this bracket? It changes. That's why you've got to look closely. 2. 1, 2. Both of these are in that bracket. So right here. Okay. Now it says, write an addition sentence for the diagram showing the decomposition of 4/5 indicated by the braces. Now they're calling the braces the brackets. They can be called by either thing. So this is a lot of big words to say, hey, make an addition sentence with all of this. So we've got 4/5. You know what? Let me write that just a little smaller. 4/5 is equal to 1/5 plus 1/5 plus 2/5. You're just putting all the pieces together. Now, is that the only way to make 4/5? No, you could have done 2/5 plus 2/5. You could have done 1/5 plus 1/5 plus 1/5 plus 1/5. But that's not what the braces or the brackets are showing. They want us to create the addition sentence that matches this tape diagram. So this is the one that matches. Okay? All right. Okay. I really want you to put on your supersonic ninja glasses, whatever you want to call them. We are going to really look close at this diagram. Let me get rid of this writing. Now, this is something that's very different looking, but if you look closely, you can figure this out. You've got this, but you're going to have to look for the details. Look at this tape diagram and all these brackets everywhere. What in the world is going on? Take a minute to really look at it closely. Okay. Remember how I said you've really got to pay attention to where one hole is. Okay. Well, if I do that, I'm going to notice that my one hole bracket starts here. Okay. But look where it finishes. It doesn't go all the way to the end of the tape diagram. What's wrong here? Nothing's wrong. This is not a typo. This is not, they printed the book wrong. That's not what this is. One hole stops right here. And then there's more. And this piece is the same size as all the other pieces. This, guys, is just like if we had two one holes together and we only shaded part of the other one. Remember we did this just a few minutes ago? They gave us an extra piece. Okay? Oh, well, let's count and let's see the denominator. Be careful. 1, 2, 3, 4, 5, 6. It's got to be 6. No. Be very, very careful. This is not 6. Yeah, but 6 are shaded. It's not 6. Why? Because there are not 6 pieces in the hole. Let's count how many pieces are in the hole right here. 1, 2, 3, 4, 5. This is fifths. Okay, our denominator is 5. But there's an extra fifth. Yep, there sure is. So how many fifths do we have that are shaded? 1, 2, 3, 4, 5, 6. Ooh, we have 6 fifths. But you're not going to have the correct denominator unless you really pay close attention as to how many pieces are in the one hole. Okay? Very, very important. So this is bigger than 1. It is an improper fraction where the numerator is larger than the denominator. Okay, now let's fill in where these brackets are. This, guys, is where people get very confused sometimes and write the wrong denominator. We're going to be careful about that. These are fifths. Got to get that in our head. How many fifths are in this bracket? 1, 2. There are 2 fifths right here. How many fifths are in this bracket right here? Again, 2 fifths. How many fifths are in this bracket? 1, 2. 2 fifths. So if we wanted to create the addition sentence like they ask us to do, we would have 6 fifths is equal to 2 fifths plus 2 fifths plus 2 fifths. Okay. If we use this same diagram and created a number bond, it would look like this. Okay, so there's our number bond to match this tape diagram. This is our addition sentence to match this tape diagram. These can get a little tricky if we're in a hurry, if we're not slowing down and paying attention to how many parts are in the whole. So just slow down on these and I think you will be fine. Okay? All right, let's move to right here. Because our problem set is going to give you some tape diagrams and have you do what we've just done, but they're also going to do it backwards. What I mean is they're going to give you this and ask you to draw the tape diagram to match. Oh no, whatever will we do? We have to draw a tape diagram and it's too hard. Really? No, it is not too hard. Okay? Don't be afraid of a tape diagram. It's just a rectangle that is doing things to help you understand your math problems. Okay? We use tape diagrams in all kinds of math, not just fractions. We got this. Okay, so 6/6 is equal to 1/6 plus 2/6 plus 3/6. Okay, that is true. But now we got to show it with our picture, and our picture is going to be our tape diagram. How can we show 6/6? How can we show 6/6 with a tape diagram? Well, let's draw that tape diagram. I'm going to turn it this color. How do I know how many pieces to cut this into? How do I know? Well, if I will go and look at my fractions, they're going to help me. Every single one of these fractions has what as a denominator? That denominator is going to tell you how many pieces to cut it into. Aha. So I know I need 6 pieces here. So cut it in half. And then cut each half into 3 pieces, and we'll have 6. Okay, now 6/6, so they're all shaded in. All right. I also know by this that it takes 6 pieces to make one hole, and I'm going to label that one hole. 1, 2, 3, 4, 5, 6. I'm going to, at the top, put the bracket with a 1. Okay, your bracket doesn't have to look like those fancy ones they have printed in the book. You can just do like I just did. Okay, now, how are we going to show 1/6 plus 2/6 plus 3/6? We're going to draw the brackets on the bottom to cut this into these smaller pieces, just like our book had for us to see at the beginning. So I'm going to draw this or show this 1/6. So I'm going to take one piece and just write 1/6. See, I'm labeling it so I know, but I'm also putting that bracket there. And then I'm going to show 2/6. So there's 1, 2. I can make those a little longer if I need to. 2/6. And then I'm going to show 3/6. 1, 2, 3. So that is all there is to it. So it's just kind of going in reverse. Instead of you creating the addition sentence, they've given it to you, but they want you to show it with our tape diagram picture. Okay? All right, so we're going to go to our problem set. So you picked up your materials at school, and in them was our brand new workbook for Module 5, Grade 4, Module 5. Okay, this is the very first lesson, so turn to page 1. Okay, this particular workbook only has Module 5 in it, so you don't have to worry about there being another module to work around or sift through. Okay, and we're going to do a few of these problems together. Okay, so if you get going with these and you don't feel like you need the help, if you want to stop this and then check your answers, you can do it that way. Or if you are unsure and you would like to just work alongside with me right now, get your workbook out and we will do that. Okay? So either way, on these beginning lessons, work with me or stop the video right now, work your problems, and then check yourself by continuing the video to see how you did. Okay? All right. Now they have done letter A for us. They want us to draw a number bond, write a number sentence, and all of that is going to match our tape diagram, and the first one is done for you. Okay, so these all have tape diagrams, but what's missing is the number sentence and the number bond. So that's what we've got to add. Okay, so for this one, the very first thing we're going to do is to count how many pieces are in the whole so we know our denominator. Okay, we are not going to let that trick us. So if you need to trace over that bracket, you do that. You don't have to, but I'm just trying to emphasize we've got to check how many pieces are in the one hole. All right, how many pieces are in this? 1, 2, 3, 4, and 5. So our denominator is 5. How many are shaded? 1, 2, 3, 4. Okay. All right, so that gets us off to a good start. So I can let that be part of my number bond. I know that this piece is just 1/5. These are all fifths, And 1, 2, 3, this is 3/5. So my bubbles that come off of here, that looks like a 6, doesn't it, guys? I'm going to make sure sometimes we write quickly and that 5 can look like a 6. There we go. 1/5 and 3/5. And that number bond is just saying when I add these two, I get that right there. So let's turn it into an addition sentence. 4/5 right here is equal to 1/5 plus 3/5. Okay. All right. Moving over here. We are going to count how many pieces are in the hole to begin with. So we've got 1, 2, 3, 4. So our denominator is 4. How many are shaded? 1, 2, 3. That's the beginning of our number bond. How many are in this bracket? Well, that's 1/4. And be careful because when you see 3 shaded, you almost want to say thirds. That's not thirds. There are 4 pieces in the hole. Okay, but this is another 4th, and this is another 4th. So I'm going to need 3 bubbles coming off of this. Okay, and then I would need my addition sentence, which is going to be 3/4 is equal to, and add those up, 1/4 plus 1/4 plus 1/4. Okay. And then letter D. Okay. We've got 1, 2, 3, 4, 5, 6 total pieces in the hole. So that is our denominator. How many are shaded? 1, 2, 3, and 4. We've got 4/6. Okay. Here we've got 1, 2, 2/6. Here we've got 1, 2, 2/6. So 2/6 plus 2/6. Our number sentence, 4/6 is equal to 2/6 plus 2/6. Okay, so this whole lesson is about decomposing these fractions, breaking these fractions down, being able to figure out from a diagram what the denominator is and what fractions are being added to equal the fraction that is being shown by that diagram. Okay. All right. I am going to show you, let's see. I'm going to show you at least maybe 1 or 2 more because I want to jump to the ones that are a little bit bigger than one hole. And then I'm going to let you finish the rest of these that are the tape diagram problems. I am going to jump to the end of the problem set, or the second page where you have the addition sentence and have to draw the tape diagram. I am going to do some of those with you also. So even though I may not do every single problem with you, I do want you to try all of them. And if you are really gung-ho and liking fractions and you want to do the homework pages, you can. That is not a have to, but I do want you to do the problem set pages. Okay, so we're going to jump over letter E. Letter E is kind of like the ones we've just been doing, but I want you to look at, we're going to do F and G together. Okay, so let's look at F. Remember what we always do first. How many pieces are in the one hole? Well, let's pay attention to where that bracket starts and stops. It stops right here. So if I'm going to count how many pieces are in the one whole, I've got to stop right there. 1, 2, 3, 4. So I know that my fraction is going to have 4 as a denominator, not 5, 4. Now, does it have an extra piece? Yes, but that does not make these fifths. These are fourths because 4 pieces is in the one whole. How many pieces do I have shaded? I have 1, 2, 3, 4, 5. That goes on top. This fraction is larger than 1. You can see that by looking at the tape diagram, but you can also see that in our fraction now that we've written it. Okay. Now, let's look at the brackets on the bottom. This bracket stops right here. It goes from here to here. How many pieces is that? 3. These are fourths, so that's 3/4. 3/4. This bracket is just has 1 piece, so that's 1/4. This bracket just has 1 piece, 1/4. So our number bond is going to have 3 bubbles, 3/4, 1. What am I doing? What am I doing? 1/4 and 1/4. If you don't circle those, it's okay, because sometimes we're a little, don't have a lot of space. But there you go. 3/4 and 1/4 and 1/4. The math problem would look like 5/4 is equal to 3/4 plus 1/4 plus 1/4. So these tape diagrams are just like the ones we did right before this. It's just that our beginning fraction is an improper fraction. And so to get started correctly, you've got to pay attention to how many pieces are in the whole. Okay, let's jump over and do G. Let's see, change to that color. How many pieces are in the whole thing? Not the whole thing, that's not the good way to say it. How many pieces are in the one whole? Just 3, because one whole stops right there. Okay? It's like they have 2 one wholes and they've put them right beside each other. Okay? So how many pieces are in the whole? Well, 3. But how many pieces do I have? I have 1, 2, 3, 4, 5. I have 5/3. Okay. How many thirds are right here? Well, just 2. This is 2/3. And how many are right here? Another 2/3. And how many are right here? Just 1/3. Okay. So my number bond for right here would be 5/3, 2/3, 2/3, 1/3. Okay. Turn that into an addition sentence, and we've got 5/3 is equal to 2/3 plus 2/3 plus 1/3. Once you get this is super simple. Or once you get this, the number bond is super simple. You've just got to pay close attention to the details in your diagram. Okay? All right. So that's how those work. The problems that I've not worked with you, I do want you to try on your own. Okay? All right, I want to show you this right here. So if you would turn to, I've got a workbook here right in front of me. This should be on page number 2, but it's also number 2. So go down and find that. It's towards the bottom half of the page over here. Your problem set does go to the other page as well, because these are spread out. So you'll finish over here. But I'm going to work a couple of these at least with you. Now, draw and label the tape diagrams to model each decomposition. Okay, so we're going to do that today. That's important. It just gives you a great understanding of what we're doing. All right, 1 or 1 whole, is equal to 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. All right. Now, look at your denominator. That's a very important number as to, it tells you or helps you know how to draw this tape diagram. We know it's going to be in the shape of a long rectangle. That's what's nice about a tape diagram. They're always the same shape. But how are we going to cut it? We are obviously going to cut this into 6 pieces. We're going to draw them as equally as we can. We know they're not going to be perfect. We're not looking for perfect. We're just going to make it as close as we can. I know that these 6 pieces are going to make my 1 whole. So I'm going to label it because it did ask me to label. Okay, so I'm going to have 1/6 plus 1/6 plus 1. You can shade those because we have all of those. But we've definitely got to label them. 1/6, 1/6, and your little brackets that you draw are gonna help you label your fraction pieces. On this one, we have a lot of little pieces. Okay, that's all there is to it. Now, when we get into one like this, some of the pieces are unit fractions and some of them are a little larger. So we've got 4/5. I've got to cut this into 5 pieces. Okay, I have 4 of them, so I'm going to shade 4 of them. Now I've just got to draw my brackets. I'm going to start with my bracket on the top to tell me that this is 1 whole. That's an important bracket as well. I'm going to show 1/5. I'm going to show 2/5 and 1/5. Okay. Oh boy. Now this is, you work this one just the same, but I'm oh boying this one right here because at quick glance, it's the larger than 1, the improper fraction type. So let's not be scared of this. It is a little different, but we're going to give it a try. I've got 11/8. So same thing. We start with a rectangle. I'm going to cut my rectangle Give me just a second because I made that just too big. I didn't have any extra space. Okay, I'm going to cut that rectangle into 8 pieces because that's what my denominator is showing. So 8 pieces. Okay. But guys, I have 11 of them. I have 11 of them. Okay, well, I know that this right here is 1 whole. These 8 pieces. Mark your 1 whole before you try to show the rest of the pieces. Okay? So I know I've got 8 pieces here. 4, 5, 6, 7, 8. But there's 11 of them, so this is not quite enough shaded pieces. So I'm going to add on, let's see, that would make 9, 10, 11, and I'm going to shade those 2. But because I have my bracket and it stops right here, I can tell, oh, this is an improper fraction. It's larger than 1. Now all I do is label the ones on the bottom. Okay? So I first need to show 7/8. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, that's 7/8. And then I need to show 1/8 right there, so just one little guy right here. And then I need to show 3/8, and that's exactly how many are left, is 3/8. Okay. So if you're marking your brackets and you don't have enough shaded pieces to make all of these smaller pieces, that might be an indication, or that might be a clue that, hey, I might not have drawn it exactly right. Let me go back and double check. Okay. All right, so that is an example of how to do one that is larger than 1. Same way, you've just got to pay attention to where your bracket stops and then add on your extra pieces so you have the right number pieces shaded. Okay. All right. So you are going to continue with those. If I switched to the last page, and I'm going to look at G really fast on the very last page of your problem set, because it gives you the problem, it gives you the beginning fraction in a little bit different form. Instead of it looking like an improper fraction, it's a mixed number. It's a whole number and a fraction. So let's just look at letter G really quick. It says 1 2/3. So I have 1 whole and then I have 2/3. Okay, and paying attention to all of my fractions, I know I'm dealing with thirds. So I'm going to have 1 whole. Remember, these are thirds. And then I'm going to have 2/3. Okay, so I'm going to have 1 whole. And then if I drew a second one, I'm only going to have 2/3 of that one. So this is 1 whole. And this is 1 whole if I go all the way to the end, but by me just shading 2 pieces, I'm showing 2/3. So I'm showing the 1 whole and I'm showing the 2/3. It's like I'm showing it in 2 separate things, but they're right beside each other, so it's what I have all together. Okay. So this is equal to 1. So when I draw my brackets, I can write 3/3 because I know that's the same as 1, or I could write 1. I could write either one. I don't want both because I don't want to think it's double what I have, but I can choose to write 3/3 or I can write 1, either way. And then here I have, here you have the 1. That's what we're showing right here. And then here you have the 2/3, which we would show right there. So this might look complicated at first, and it's really not. We're just showing with 2 separate tape diagrams side by side. Okay. All right. So that's another way to do that, another way to show that. I want you to try all the problems in your problem set, and then once you've done that, you're going to go into My Google Classroom and you're going to go to the exit ticket. And I do want you to go in and try all the problems, and then remember to turn it in correctly. Remember, you've sometimes got to turn it in and then go back and hit submit, or hit submit and then go back and hit turn in. Okay? You guys work so hard at home. I'm so proud of you. Remember, these are regular school days at home, and we want to get this done so that we're counted present at school and so that we do not come back and are behind. These are brand new lessons, and we need you to do them, and we know that you can. So work hard, guys, and we will see you back at school, and I can't wait. So this is Wednesday's lesson, and then there'll be Thursdays and Fridays. Keep going. You can do it. See you later.